Good afternoon, students. Welcome to Pre-Runner Gate class. In this class, we are going to discuss about multiplexer and problem based on multiplexer. Okay, multiplexer is a combinational circuit and it has an input lines and 2 power and data inputs, and it has only one output lines. Okay, based on the selection input, the input is selected to the output lines. Okay, suppose you will be having two variable function means you will be having 2 power n input lines. Okay, 2 power n input means that is equal to 4. So 4 cross 1 multiplexer. Okay, that is 4 cross 1 multiplexer. Suppose if you are having 3 selection lines means, okay, if your selection input is 3 means your input line will be 2 power 3. So that is equal to 8. So it will be 8 cross 1 multiplexer. Okay, based on the selection input lines will be there in your multiplexer, but you will be having only one output lines. Okay, this is the logic diagram of our 2 cross 1 line multiplexer. The circuit has two inputs, I1 and I2 are the inputs, and S is the selection input. Okay, and Y is the output. Okay, this is a 2 cross 1 multiplexer. I0 is the input and I1 is the input, and S is the selection input and Y is the output. This is the truth table for our 2 cross 1 multiplexer. So if this is a single input means you will be having two possible combination, either it may be either 0 or 1. Okay, single variable means you will be having only two zero, either it may be 0 or 1. Okay, if you are having two variables means it may be 0 0 or 0 1 or 1 0 or 1 1. Okay, if your selection input will be 0 0 or 0 1 or 1 0 or 1 1. If you are having three variable function means your selection input will be 0 0 0 to 1 1 1. Okay, based on the selection input you'll be having your input combination. Okay, now in this circuit, S is the selection input. So if S is equal to 0, I0 is selected to the output line. Okay, if S is equal to 1, I1 is selected to the output line. Based on the selection input, the input is selected to the output line. Okay, when S is equal to 0, the output of NOT gate will be 1. At that time, the AND gate, the upper AND gate will be enabled. So I0 is selected at the output line. When S is equal to 1, the lower AND gate is enabled. That is, I1 is selected at the output line. Next one, 4 cross 1 line multiplexer. As I told you already, based on the selection input, the input is selected at the output lines. This is a S1 and S0 are the selection input. So it is a two variable function. So we'll be having four possible combinations: 0 0 0 1 1 0 and 1 1. And Y is the output. Okay, when your selection input is 0 0, I0 is selected at the output lines. When your selection input is 0 1, I1 will be selected at the output. When your selection input is 1 0, I2 will be selected. Okay, when your selection input is 1 1, I3 will be selected at the output lines. This is the logic diagram of our 4 cross 1 multiplexer. I1 and I2, I3 are the input lines of the multiplexer, and S1 and S0 are the selection input of the mux, and Y is the output of this multiplexer. Okay, when the selection input S1 and S0 is equal to 0 0, the first AND gate, that is I0, is selected at the output. The first AND gate is enabled and I0 is selected at the output. That is, whatever the value present in this I0, that will be your output. Okay, when your selection input is 0 1, at that time the second AND gate is enabled. That's why I1 is selected at the output. Okay, so whatever the input present in the I1, that will be your output. You will be getting your output as I1. Okay, next one, when your selection input is 1 0, that is S1 and S0 is equal to 1 0, I2 will be selected at the output line. Okay, next one, when your selection input 1 1, when your selection input is 1 1, I3 will be selected to the output lines. Finally, you have to write the expression for your output y. Y is equal to I naught into S1 dash S naught dash plus I1 S1 dash S naught plus I2 S1 S naught dash plus I3 S1 S naught. Next one, implementation of Boolean function using mux. Now you are going to implement the Boolean function using multiplexer. Okay. First, let's see the procedure how to implement the Boolean function using multiplexer. Okay. Implement the following Boolean function using 4 cross 1 multiplexer. F of a comma b comma c is equal to summation of min terms 1 comma 3 comma 5 comma 6. First, you have to find out the selection lines. How many selection lines you need to implement this function? Okay. First, you have to identify the given variables. This is a 3 variable function. So, your n value is equal to 3. N is equal to 3. Selection line is equal to n minus 1. So, n is the variables. So, here you have to substitute 3. Okay. Select lines is equal to 2, 3 minus 1, that is equal to 2. So you'll be having two selection lines S1 and S0. Next, you have to find out which type of multiplexer you need to implement the given function. Okay, that is 2 power n minus 1. Here n is 3. So 2 power 3 minus 1, you'll be getting 2 power 2. Okay, 2 power 2 is nothing but 4. So you need 4 cross 1 multiplexer. So you need 4 cross 1 multiplexer to implement the given full Boolean function. Okay, your selection input will be 2 and you need 4 cross 1 multiplexer to implement the Boolean expression. Okay, next one. Now we are going to implement the Boolean expression using 4 cross 1 multiplexer. First, you have to write the min terms, possible combination. Okay, if this is a 3 variable function, so you will be writing 0 to 7. Okay, in the implementation table, you have to write the min terms 0 to 7, and this is A dash. The column wise, you have to write D0, D1, D2, and D3. D0, D1, D2, D3 represents the input lines. Okay. Now you have to circle the given min terms. Okay. First, you have to write all the possible all the possible min terms for the 3 variable function, that is 0 to 7. First, you have to write the min terms. After that, you have to circle the given min terms. Now look at the problem. F of a comma b comma c is equal to summation of min terms 1 comma 3 comma 5 comma 6. So you have to circle the min terms 1 3 5 6. Okay, 1 3 5 6. Okay, you have to circle the min term 1 3 and 5 6. Now you have to write the values of your input. Now let's see how to write the values of the input. Okay, look at the first column. Both the minterms are not circled. If both the minterms are not circled, means you have to write 0. Okay, you have to put 0. If any one of the minterm is circled, means you have to write the variables which is in the row side. Okay, look at the second column D1. In this, both the minterms are circled. If both the minterms are circled, means you have to write 1. Okay, you have to put 1 for the value of D1. Okay, next in the third, look at the third column, that is D3. Two minterms are there, that is 2 and 6. Okay, if one minterm is circled, okay, if one minterm is circled, means you have to write the variables which is in the cost row wise. Okay, the variable a is present in the row wise, so you have to write the variable here. Okay, that is the value of our D2. Okay, next, now move on to the column D3. In this, you will be having two minterms, 3 and 7. The minterm 3 is circled and minterm 7 is not circled. Okay, If both the minterms are circle means you have to put 1. If any one of the minterm is circle means you have to see the variables which is in the row wise. Okay. In this the minterm 3 is circled, so you have to see the variables which is in the row wise row side. In the row side you will be having a dash, so the value of d3 is a dash. Okay. Now we are going to implement the function using 4 cross 1 multiplexer. Okay, this is the diagram of the multiplexer, 4 cross 1 multiplexer. First you have to draw the 4 cross 1 multiplexer. D0, D1, D2, D3 are the inputs of the multiplexer, and S1 and S0 are the selection input of the multiplexer, and Y is the output of this 4 cross 1 multiplexer. Now you have to see D, where you have to connect D naught. D naught, the value of D naught is 0. So the D naught should be connected to 0. That's why we are connecting this D naught to ground. Okay. Next one. Now look at the value of D1. D1, the value of D1 is 1. Okay. So it should be connected to logic high. Okay. You can put plus 5 or 1. Okay. Now D1 should be connected to 1. Okay. Next, see the value of D2 and D3. The value of D2 is A. So D2 should be connected to A. Okay. A is connected to D2. Now you have to see the value of D3. The value of D3 is A dash. Okay. So D3 should be connected to A dash. Okay. Already D2 is connected to A. So you can connect one NOT gate, then you will be getting the output of NOT gate will be A dash. Okay. So the NOT gate input is connected to A, the NOT gate output will be A dash, that is connected to D3. Next one, B and C are the control input, that is selection input. Okay. Now the Boolean function is implemented using 4 cross 1 multiplexer. Now let's see how the 8 cross 1 mux is implemented. How the Boolean function is implemented using 8 cross 1 multiplexer. This is the given function f of a comma b comma c comma d is equal to summation of minterm 0 comma 1 comma 3 comma 4 comma 8 comma 9 comma 50. This is the given minterm. This is a 4 variable function. Okay, a b c d is given, so it is a 4 variable function. So n is equal to 4. Okay. A, B, C, D. First, you have to find out the select lines. Select lines is equal to n minus 1. You need n minus 1 select lines to implement the Boolean function. N minus 1 is equal to 3. Okay. S2, S1 and S0 are the selection inputs. Next, you have to find out which type of multiplexer you need to implement the given Boolean expression. Okay. That is 2 power n minus 1 to mux. Okay. 2 power n. Here you have to substitute the n value. What is n value? The given variables. Okay. The given variables are 4. So n value is 4. So here you have to substitute 4. 2 power 4 minus 1. 4 minus 1 is 3. So 2 power 3, you'll be getting 2 power 3. 2 power 3 is 8. Okay. So 8 to 1 multiplexer. You need 8 cross 1 multiplexer. Okay. To implement the given Boolean expression, you need 8 cross 1 multiplexer. Now let's see the implementation table. As this is a 4 variable function, you will be having minterms from 0 to 15. First, you have to write the possible minterms 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, first you have to write all the possible minterms. Next, you have to circle the given minterms. In this problem, the given minterms are 0, 1, 3, 4, 8, 9, 15. So you have to circle the minterms, given minterms. 0 is circled and 1 is circled, 3, 4 circled, 8, 9, 15. Okay. After that, you have to write the value of D naught. If look at the D naught column, In the D naught column, the minterm 0 and 8 is there. Okay, both the minterms are circled, so you have to put 1. If both the minterms are not circled means you have to put 0. If both the minterms are circled means you have to put 1. If any one of the minterm is circled means you have to see the variables which is in the row side. Okay. In the first column, both the minterms are circled, so you have to put 1. In this, look at the second column, that is D1. And the minterm 1 and 9 are there, okay? Both the minterms are circled. So, if both the minterms are circled means you have to put 1 here, okay? Next, look at the third column, that is D2. In this, both the minterms are not circled, so you have to put 0. Look at the D3 column. In this, you'll be having two minterms, 3 and 11. The minterm 3 is circled, so you have to see the variables which is in the row wise. Okay, in the row wise, you will be having a dash, so you have to put a dash here. Okay, look at the fifth column, that is D4. Two minterms are there, they are 4 and 12, but the minterm 4 is circled, the minterm 12 is not circled. Okay, minterm 4 is circled, so I have to see the variables which is in the rows wise. Okay, that is a naught is there, so I have to write a dash. Okay, next one, look at the D5 column. You'll be having two minterms, 5 and 13. Both the minterms are not circled, so directly you can put 0 here. Okay, next one, come to the next column, D6. You'll be having two minterms, 6 and 14. Both the minterms are not circled, so directly you can put 0 here. Last one, come to the last column, D7. Two minterms are there, 7 and 15. The minterm 15 is circled, so you have to see the variables which is in the second row. In the second row, the variable a is there, so you have to write a here. Okay, so your D7 value is a. Okay, next one. Now you are going to implement the function using 8 cross 1 multiplexer. As this is a 8 cross 1 multiplexer, you will be having 3 selection inputs and 8 input lines. Here, look at the mux, 8 cross 1 mux, S0, S1 and S2 are the selection input, and D0 to D7 are your input lines, and Y is the output lines. Okay. Look at the value of D0 and D1. D0, the value of D0 is 1 and the value of D1 is also 1. So, the input D0 and D1 should be connected to 1. Okay. D0 and D1 should be connected to 1. Next, see the value of D2, D3. Okay, the value of D3 and D4 are A bar. Okay, so the input D3 and D4 should be connected to A dash. D3 and D4 should be connected to A dash. Okay, here you have to draw one line and it is named as A, and the input of NOT gate is connected to A, so your output will be A dash. That should be connected to D3 and D4. Next one, what is the value of D2? The value of D2, D5 and D6 are 0. The value of D2 is 0, D5 is 0 and D6 also 0. So, the three input lines should be connected to 0. D2, D5 and D6 are connected to 0. Next, see the value of D7. The value of D7 is A. So, D7 should be connected to A. D7 should be connected to A. Okay. These three are the selection input B, C, D. Okay. Now the Boolean function is implemented using 8 cross 1 multiplexer. Now let's move on to the next problem. The logic realized by the circuit shown in figure is Four options are given. F is equal to AC and F is equal to A XOR C, F is equal to BC and F is equal to B plus C. Okay, this is the diagram, given diagram 4 cross 1 max. As this is a 4 cross 1 max, you will be having two selection input S1, S0 and S1, and you will be having four input lines I0, I1, I2 and I3. Okay, and you'll be having only one output lines that is named as F. Okay, the selection inputs are A and B are the selection inputs, and I0 and I1 is connected to C, and I2 and I3 connected to C dash. Now let's see how to solve the problem. First, you have to write the function table for this multiplexer. A and B are the selection input. F is the output. Okay, based on this, as we know that based on the selection input, the input is connected to the output lines. Okay. First, you'll be having two selection inputs. So, you'll be having the possible combination 0, 0, 0, 1, 1, 0 and 1, 1. That is written in the table. Okay. Next, you have to write the output. Okay. When your selection input is 0, 0, I naught is selected at the output. Okay. Next one, when your selection inputs are 0, 1, I1 is selected at the output. Next one, when your selection inputs are 1, 0, I2 will be selected at the output side. Okay. Next one, the last one, when your selection input is 1, 1, I3 will be selected at the output. Okay. First, you have to write the function table. After that, the mean how we are going to implement the variables in min terms. Okay, 0, 0 that represents the min term a dash b dash. 0, 1 is represented in min term as a dash b, and 1, 0 is represented in min term as a b dash, and 1, 1 is represented in min term as a b. The min-term combinations should be multiplied with the input lines. Okay, so you'll be getting a dash b dash I naught, a dash b I1, a b dash I2 and a b I3. Okay, these are all the output function. Okay, f is equal to a bar b bar I naught plus a bar b I1 plus a b bar I2 plus a b I3. Now we are going to substitute the I naught value, I2 value, I3 and I4 value. A dash b dash, what is the I naught value? The I naught value is C. Okay, the value of I naught and I1 is C only. So you have to substitute C for I naught and I1. Okay, A dash B dash C plus A dash B C plus A B dash of I2. What is I2 value? I2 is connected to C dash. So you have to substitute C dash here. Okay, A B dash C dash, and I will be having one more product terms, that is AB I3. Okay, here you have to substitute I3 value. What is I3? I3 is connected to C dash. So you have to substitute C dash here. Okay, instead of I3 you have to write C dash. A B C dash. Okay, A bar B bar C. Now come to the next line ma. A bar B bar C plus A bar B C plus A B bar C bar plus A B C bar. Okay. Next one, f is equal to, now you have to check whether any common variables are there in our product terms. Look at the first two product terms. A bar C is common in both the product terms. Okay, so you can take A bar C common, then it will become A bar C of B plus B bar. Okay, B plus B bar is nothing but 1. Okay, so this will become A bar C. Okay, plus A B bar C bar. Remaining two product terms are A B bar C bar plus A B C bar. Now you have to check is there any common variables are there in our product terms. A B bar C bar plus A B C bar. A C bar is common in both the terms. So you can take A C bar common. Then it will become A C bar of B bar plus B. B bar plus B plus B bar is equal to 1. Okay. So This can be minimized as a bar c plus a c bar. A bar c plus a c bar is nothing but XOR function. So you can write this expression as a XOR c. Okay. Now let's move on to the next one. S2 and S0 are select lines and X7 and X0 are input lines. S0 and X0 are LSBs, the output Y is. You have to find out what is the expression for your output Y. Okay, this is a, here you will be having 3 selection lines and 8 input line. So it is a 8 cross 1 max. Okay, 3 selection lines are there and 8 inputs are there, so it is a 8 cross 1 mux. Okay, and the selection input S2 is connected at the output of OR gate. The input of OR gate is 0 and C, so the output of OR gate will be 0 plus C. Okay, the value of S2 is 0 plus C, that is equal to C. Okay, you can write it as C. Okay, here the output of OR gate is C. Okay, now look at the input lines. What are all the input lines connected to 1? X0 is connected to 1 and X3 is connected to 1 and X5 is connected to 1 and X6 also connected to 1. So first you have to find out the minterms for the function. Okay, y is equal to f of c comma b comma a. They are your selection input. Okay, summation of minterms 0, 3, 5, 6. Okay, X0 is connected to y. That's why here written as 0 comma 3 comma 5 comma 6. Okay, x0, x3, x5 and x6 is connected to 1. That's why we written the minterm as summation of minterm 0, 3, 5 and 6. Okay, f is equal to, now we are going to write the minterms representation for this number. Okay, 0 is represented in minterm as 0 0 0. Since this is a 3 variable function, 0 is written as 0 0 0. That 0 0 0 is represented as c bar, b bar, a bar. Okay, next one 3. Minterm 3 is represented as, 3 is nothing but 0 1 1. Okay, 0 1 1. That's why it is written as c dash b a. Next product term 5. Okay, here you have to write the in terms for 5. Okay, 5 is nothing but 0 1 0 1 is 5, so 1 0 1. So that 1 represents C, that 0 represents B dash, that 1 represents A. So it is written as C B dash A. Okay, next product term 6. You have to write mean terms for 6. Okay, 6 1 1 0 is 6. So C B A dash. Okay, this is written as C B A dash. Now we are going to simplify the expression. For that you have to check any, is there any common variables are there in your product terms. So look at the first product term, C bar B bar A bar and C bar B A. C bar is common in both the terms, so you can take C bar common, then it will become C bar of B bar A bar plus B A plus, look at the third and fourth product terms, C B dash A and C B A dash. In both the terms, C is common, so you can take C common and this will become B dash A plus B A dash. Okay, C dash, next line C dash A bar plus B A is nothing but B X NOR A. Okay, this is the logical expression for our NOR gate. So it can be written as B X NOR A plus C of B bar A plus B A bar. This is the logical expression for our XOR gate. So it can be written as A XOR B. Next one, C bar of A plus B whole bar. Okay. Now the NOR function is written like this. The complemented the complement of XOR gate is XNOR gate. So it is written as A XOR B complement. Okay. This XNOR function is written as A XOR B complement plus C of A XOR B. Okay. This is your answer. C bar of A plus A XOR B complement plus C of A XOR B. This will be your answer. Okay. Next one. Now let's move on to the next one. The Boolean function f implemented in figure using two input multiplexer is, this is a 2 cross 1 mux. Here you'll be having two 2 cross 1 mux. Okay. The first look at the first first 2 cross 1 max. The selection input is B and our input is C and C dash. Okay, so the output will be, first you have to write the expression for the first 2 cross 1 max. Okay, what will be the output function? F is equal to C, F is equal to B C bar plus B bar C. Okay, the input variable should be multiplied with the minterms for the selection input. The selection input B is written as B dash B. Now it should be multiplied with the input lines. Okay, so it will be B C dash plus B dash C. Okay, that is connected to the selection input of the second 2 cross 1 mux. Okay, the output of the first mux is connected to the selection input of the second 2 cross 1 mux. Okay, look at the second 2 cross 1 mux. Okay, the selection input is named as E, so it is written as E dash E. Now the E dash should be multiplied with the input I naught. I naught value is 0, so E complement should be multiplied with 0. That is written here. F is equal to 0 into E complement plus you will be having another one function, that is EA. Okay. Now the I1 value is A, that should be multiplied with E. So A into I, that is equal to, now 0 into E complement will become 0. So you'll be having AE only. Now you have to substitute E value here. Okay. What is E value? E value is nothing but your output of the first 2 cross 1 multiplexer, B bar C plus BC bar. Okay, that should be multiplied with the variable A. Then you will be getting your final answer. Okay, F is equal to A B bar C plus A B C bar. This is your answer. Okay. Now let's move on to the next one. The following circuit X is given by, here you'll be having two 4 cross 1 multiplexer, and as this is a 4 cross 1 max, you'll be having 4 input lines and 2 selection inputs. In each multiplexer, you'll be having 4 input lines and 2 selection lines. Okay, the first, look at the first 4 cross 1 max. The selection lines are named as A and B, and your I naught value is 0, I1 value is 1, and I2 value is 1, and your I3 value is 0. So no need to consider I naught and I3. You have to consider I2 and I1 value only. Okay. So you have to write the minterms for when I1 is selected at the output of the mux. When your selection input 0, 1, I1 is selected to the output. When your selection input is 1, 0, I2 is selected to the output. First, you have to write the expression for I1 and I2. I1 and I2. First, you have to write the expression for I1 and I2. A bar B plus AB bar. Okay. This is A bar B and plus AB bar. This is the output expression for the first 4 cross 1 multiplexer that is connected to the selection input, first selection input of the second 4 cross 1 multiplexer. Okay, the output of the first multiplexer is connected to the one selection input of the second 4 cross 1 multiplexer. Another one selection input of the second multiplexer is connected to the C. Okay, connected to the variable C. Okay. Look at the second 4 cross 1 multiplexer. I naught value is 0, I1 value is 1, and I2 value is 1, and I3 value is 0. So no need to consider I naught and I3. If you are multiplying the min terms with I naught and I3, you will be getting 0 only. So no need to consider I naught and I3. Have to consider I1 and I2 only. Okay. Now you have to write the output expression for the second 4 cross 1 multiplexer. Y is equal to S1 dash S naught plus S1 S naught dash. Okay. Y is equal to S1 dash. That is when your selection input S1 and S naught is 0, 1. That is 0, 1. I1 will be connected to the output. That represents the min term S1 dash S naught. That should be multiplied with the I1 value. Here I1 value is 1. So directly you can written as S1 dash S naught plus next one, when I2 will be connected to the output, when your selection input is 1, 0, I2 is connected to the output. That 1, 0 represents the min term S1 S naught dash. Okay, that is written here S1 S naught dash. So the output of the second multiplexer is Y is equal to S1 dash S naught plus S1 S naught dash. Okay, Y is equal to S1 dash S naught plus S1 S naught dash. Here you have to substitute the value S1 because one enable input of the second mux is S1. So you have to substitute the S1 value here. S1 is nothing but output expression of the first multiplexer. So your S1 value will be A XOR B. So instead of S1, you have to substitute A XOR B here. Okay. S1 dash. S1 dash means you have to take complement for S1. If you take complement for X1 means this expression will become X nor expression. Okay. A X nor B. Okay. S1 is A X or B. Taking complement for S1, this will become A X nor B. So you can write the expression as Y is equal to A X nor B. And here you have to substitute the value of S naught. What is S naught value? S naught value is C. So you have to substitute S naught here. Okay. S naught value here plus S1. What is S1? S1 is nothing but A XOR B. So you have to write A XOR B. What is S naught dash value? S naught dash value will be C dash. Okay. So you have to substitute C dash here. Okay. You can simplify further. Okay. So you can write this expression as A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C. This is your final answer. Next one. Now let's move on to the next one. The Boolean function realized by the logic circuit shown is, this is a 4 cross 1 multiplexer. As you know that in 4 cross 1 multiplexer, two selection lines are there and you'll be having 4 input lines. The two select lines are named as A and B, and I0 is connected to C and I1 is connected to D, and I2 is connected at the output of the NOT gate. That is, input of the NOT gate is C, so your output will be C dash. So I2 is connected to C dash. Okay, next one I3. I3 is connected to the NAND gate, C dash D dash. So the output of NAND gate will be C dash D dash. Now you have to write the output expression for this 4 cross 1 mux. First you have to write the min terms for the selection input. Okay. 0 when S1 and S0 is equal to 0, 0. I0 is connected to the output, and S1 and S0 is equal to 0, 1. I1 is connected to the output. Okay. When your selection inputs 1 0, I2 will be connected, and 1 1, when your selection input is 1 1, I3 will be selected. Okay, first you have to write the possible min terms for S1 and S0. Here the two selection lines are named as A and B, so you can write the min term as A dash B dash, A dash B, A B dash, and AB. Now we are going to write the final expression for this 4 cross 1 max. F is equal to a bar b bar, a bar b bar, that should be multiplied with your I naught. What is I naught value here? Sorry, first write it as I naught, then we can substitute the value. A bar b bar into I naught plus, next one is a bar b, that should be multiplied with I1. So it is written as in a bar b I1 plus, next one, a b bar, that should be multiplied with I2. A b bar I2 plus a b into I3. So it will become a bar b bar c plus a bar bd. Now you have to substitute the I naught value here. What is your I naught value? I naught value is C. So you have to substitute C here. A bar, B bar, C plus what is your I1 value? I1 value is D. Okay. So here you have to substitute D instead of I1. A bar, B, D plus third product term A, B bar, I2. A, B bar, I2. I2 value is C. C dash. Okay, the NOT gate output will be C dash. So C complement plus AB into what is I3 value? I3 value is C bar D bar. Okay. Here the input of the NAND gate is C D bar. So output will be C bar D bar. Now you have to write the corresponding minterms for this function. A bar B bar C represents the minterm 2, 3 and A bar BD represents the minterm 5, 7 and A B bar C bar represents the minterm 8, 9 and A B C bar D bar represents the minterm 12. Okay. Finally, you have to write all the minterms. F is equal to summation of minterms 2, 3, 5, 7, 8, 9, 12. Okay. Using K-map also you can simplify the expression. Okay. Now let's move on to the next one. The logic function implemented by the circuit below is, this is a 4 cross 1 multiplexer. Output is F and your selection inputs are P and Q, and you'll be having 4 input lines I0, I1, I2 and I3. First you have to find out what is I0. Okay, before that 2 NOT gates are connected. Okay, the input of the first NOT gate is connected to ground, so the output of the first so the input of the first NOT gate is 0 because it is connected to ground, so output will be 1. Okay, so the output of the first NOT gate is 1, that is connected to the input of the another one NOT gate. So now the input of the second NOT gate is 1, so the output will be 0. That 0 is connected to I0, so your I0 value is 0. So while writing the expression, you no need to consider I0. Okay, next one, now we have to find out the I1. Okay, what is I1? I1 is connected at the output of the first NOT gate. Okay, as we know that the output of first NOT gate is 1, so that is 1 is connected to I0. I1 is connected to 1 and I2 also connected to 1. Okay, so logic 1, the both the inputs are connected to logic 1. So while writing the final expression, you have to consider the input I1 and I2. Okay, now let's come to the fourth one, that is I3, that is connected to ground only. Okay, that is connected to ground, that represents 0. Okay, so while writing the expression, no need to consider I3. So now we are going to write the expression for F. Now you have to consider I1 and I2 only. When I1 is selected and when I2 will be selected at the output. Okay, 0, 1. Okay, 0, 0. When your selection input is 0, 0, I0 is connected. When your selection input is 0, 1, I1 is connected. When your selection input is 0, 1, I1 is selected. That 0, 1 represented as P dash Q. Okay, so your final expression will be P dash Q plus, now when I2 will be selected at the output, what is the input combination, selection input combination? 0 0 0 1 1 0. Okay, 1 0. When your selection input is 1 0, I2 is I2 will be connected 1 0. That 1 0 represents PQ dash. That should be connected to connect. Sorry, that should be multiplied with I2. I2 value is 1, so directly you can write PQ dash P dash Q. So your expression will be PQ dash plus P dash Q. That represents XOR function. This is the logical expression for our XOR function. So your option is D. F is equal to XOR of P comma Q. This will be your answer. Okay. Now let's move on to the next one. Okay. Look at the diagram. Max diagram is given. Which one of the following Boolean function is realized by the circuit? What is the, you have to find out what is the final expression of this multiplexer. Both are 2 cross 1 multiplexer. Okay, the first multiplexer, the selection input is S1. In the second multiplexer, selection input is S2. I naught is connected to W. Look at the first multiplexer. I naught. This is I naught. This is I1. Okay. As this is a 2 cross 1 max, we will be having one selection lines and two input lines. This is first input line I naught. That is connected to W. This is I2. Sorry, I1. The second input of the multiplexer that is connected to the complement of the input variable W. Okay, so W dash is connected to second input. W is connected to the first input and W dash is connected to the second output. So your output function will be W plus W dash. Okay. Okay. Sorry. Okay. F1 is equal to, first you have to find out the expression for F1. F1 is equal to S1 dash. Okay. Here the control input is S1. So mean terms for control input should be multiplied with the input. Okay, here sorry, selection input is S1. S1 dash, when a selection input is 0, the first input, sorry, I naught is connected to the output, so it can be written as S1 dash W plus S1 W dash. Okay, so the output of the first multiplexer is S1 XOR W. This is the logical expression of our XOR gate. So this can be written as S1 XOR W. Now you have to find out the output of the second multiplexer. Okay. Now the first multiplexer, the output of the first multiplexer is connected directly to the first input of second multiplexer, and it is connected to the second input of second multiplexer through the NOT gate. Okay, the output is connected directly to the first input and it is connected through one NOT gate to the second input. So now you have to write the expression for the F2. F2 is equal to S2. Here the selection input is S2. So your selection input is S2 dash. This F1 is connected. So it will be written as S2 dash F1 plus S2 F1 dash. Okay. This is nothing but S2 XOR F1. This is the logical expression for our XOR gate. So it can be written as S2 XOR F1. Here you have to substitute the F1 value. Okay. S2 XOR F1. Here you have to substitute the XOR, F1 value. F1 value is F1 is equal to S1 XOR W. So you have to substitute S1 XOR W. So you'll be getting your answer S2 XOR S1 XOR W. This is your answer. Next one. Now let's move on to the next one. In the circuit shown, W and Y are MSBs of the control input. The output F is given by. You have to find out the final expression of the second multiplexer. You'll be having two 4 cross 1 multiplexer. You have to find out the output function of the second multiplexer. Okay. Look at the first multiplexer. I naught is connected to ground. That is 0. Okay. I1 and I2 are connected to VCC, that is logic 5 volt, that represents the logic value 1. Okay, so now your I1 and I2 value is 1 1, and I3 is directly connected to ground, that means 0. Okay, so no need to consider I0 and I3. While writing the expression, you have to consider I1 and I2 only. Okay, so Q is equal to, here the control inputs are W and X. Okay, when your selection input 0 1, I1 is selected, that represents the min term W dash X, okay, into I1. So it is written here, okay, W dash X plus Wx dash. Okay, this is the output expression for our first multiplexer. Okay, Q is equal to W bar X plus Wx bar. This mean term should be multiplied with the value of I1. The value of I1 is 1, so it will become W dash X plus Wx dash. Okay, that is connected to the input of the second multiplexer I0 and I1. Okay, so your I0 and I1 value will be Q only. Okay, I2, and look at the second multiplexer, second 4 cross 1 max. I2 and I3 are connected to ground. So the logic value is 0. So no need to consider I2 and I3 while writing your final expression. Now you have to consider I0 and I1 only. When your I1 is, first you have to find out when I0 is selected and when I1 is selected at the output. Okay, when your selection input is y dash z dash, that is 0 0, that represents the min term y dash z dash, so that should be multiplied with the I naught. Okay, so you have to write the expression as f is equal to y dash z dash into I naught plus y dash z, that is second one, y dash z. Okay, y dash z into I1. Now you have to substitute the I naught and I1 and I2 is equal to Q only. I1 and I2 is equal to Q only. So you have to substitute the value of I0 and I1. Okay, y dash z dash into I0. What is the value of I0? I0 is equal to Q. That is Q is equal to W dash X plus Wx dash. Here you have to substitute W dash X plus Wx dash plus y dash z into I1. What is I value here? I value is also Q. What is Q value? W dash X plus Wx dash. So you have to write Q value here, y dash z into W dash X plus Wx dash. Okay. Next one, y dash z dash W dash plus X, W dash X plus Wx dash y dash z dash plus y dash z dash W dash X plus Wx dash y dash z. Okay. By using KMAP method, we are going to minimize the expression. Okay, this is a 4 variable function, so you need 4 variable map to implement the function. Okay, so let us take one 4 variable KMAP. It consists of 16 cells. Now we are going to put one for the given min terms. Okay, W bar X Y dash Z dash, that represents, this cell represents the min term W dash X Y dash Z dash. W dash X dash, W dash X Y dash Z dash. Okay, this one. This cell represents the min term W dash X Y dash Z dash. The second one is W dash X. W dash X Y dash Z dash. This cell represents the min term. Like that, you have to put one for the given product terms. After that, you have to group the ones. Okay, you know, here you'll be having two ones. You can group like this. Okay, you can group like this. After grouping, you have to write the product term for the grouping. Okay, first come to the group one, this one. The first you have to identify where your group is. Your group is in second row, first column and second column. When your group is in single row means you have to write the variable as it is. Okay, now your group is in single row. Okay, second row. So in the second row, the variables are present, there is W dash X. Okay, W dash X, and you have to write the common variables which is in the column side. Okay, in the column wise, the common variable is Y dash. Okay, that is written here, w dash x y dash. For next, you have to write the product term for this second one. Here also your group is in fourth row, first and second column. So you have to write the variables which is in the fourth row, wx dash. Okay, wx dash. Here your group is in two columns. So you have to see the common variables in the two columns. Here the common variable is y dash. Okay, wx dash y dash. This is your answer. Okay. Now let's move on to the next one. An 8 to 1 multiplexer is used to implement a logical function y as shown in figure. The output y is given by, this is a 8 cross 1 multiplexer. As you know that we'll be having three selection inputs, S0, S1 and S2, and I1 and I0 to I7 are input lines. The value of I0 is 0, I1 is D, and the value of I2 is 0. The value of I3 is D, and the value of I4 and I5 is 0. Next, I6 is connected to 1 and I7 is connected to 0. You have to find out the expression for this 8 cross 1 multiplexer. Okay. No need to consider I0, I2, I4, I5 and I7 because it is connected to 0. So you have to consider the input lines I1, I3 and I6. Okay. When next you have to find out when I1 is connected at the output lines. What is the corresponding mean terms for this function? Okay. A, B, C is the selection inputs. Okay. Selection inputs are A, B, C. So your selection input 0, 0, 1. Okay, that time I1 will be connected to output line. That represents the min term A bar, B bar, C. This should be multiplied with the value of I1. So it can be written as A bar, B bar, C, D. So the first product term is A bar, B bar, C, D. Okay, A bar, B bar, C, D. The next product term is when I3 will be selected at the output. When I3 will be selected 0, 1, 1. When your selection input is 0, 1, 1, I3 will be selected at the output side. 0, 1, 1 represents the mean term A bar BC. Now this A bar BC should be multiplied with I3. Now I3 value is D. So it can be written as A bar BCD. Okay. So the second product term is A bar BCD. Okay. Now let's move on to the next one. Now I6 is connected to 1. So when I6 will be connected to output? 110. Okay, 110. When your selection input is 110, I6 will be connected to output. So that 110 represents the min term A, B, C bar. That should be multiplied with the I6 value. Here I6 value is 1. So this will be multiplied with 1. So you'll be getting A, B, C dash. That is where lost product term A, B, C bar. You can simplify the expression using K-map. Okay, so this is a 4 variable function, so you need a 4 variable K-map to implement the function. Okay, A bar, B bar, C, D. First you have to put 1 for the given min terms A bar, B bar, C, D. This cell represents A bar, B bar, C, D. A bar, B bar, C, D. So you have to put 1 here. Next one, A bar, B, C, D. A bar, B, C, D. This cell represents A bar, B, C, D. So you have to put 1 here. And you will be having one more product term, that is A, B, C bar. A, B, C bar. A, B, C bar is common in both the columns. So you have to put 1, 1 here. So now you have to write the final expression. Okay, y is equal to this. Sorry, the product term for this group is A bar BC. Okay, A bar BC. Next one, A B C. So this is your answer. Okay, A bar C D. This is A bar C D. This group product term for this group is A bar C D, and this is A B C bar. Okay. Okay. Thank you, ma.